How's it going, YouTube? Don here. In this video, we're going to do number 671, second minimum node in a binary tree. So given a non-empty special binary tree consisting of nodes with a non-negative value, where each node in this tree has exactly 2 or 0 subnodes. If the node has 2 subnodes, then this node's value is a smaller value among its 2 subnodes. More formally, the property root.value is equal to min root.left.value, root.right.value always holds. Given such a binary tree, you need to output the second minimum value in the set made up of all the nodes' values in the whole tree. If no such minimum value exists, output -1 instead. So this is a really gnarly problem that took me a while to figure out. So keep in mind that if the node has 2 subnodes here, then this node's value is a smaller value among its 2 subnodes. So what does this mean? Well, we have 2 here, right? So this value is the smallest one amongst this, right? So 2 is obviously less than 5, so this holds. So we always have to have, in this case is going to be 2 in the root node, and then to the root.left, we're going to have the same node as the one above, and then we have some other value that's greater in the other part, right? And we see the same scenario over here. So we have 5 here, which is the same as the root node, and then we have a value that's greater than that in this node, right? So if you think about it, if you were to extend it, you would have, say, 7 over here. So this one would be 7, right? And then you'd have, say, 9 over here, right? And take a look at this. If you take a look here, we know for a fact that this node is going to be the same as this node, so we can essentially ignore it, and we're only concerned with what's going on in the root here. So we can see here that the root is 2, that's a minimum value, and then you have then you have 5, which is greater than it, and then you have 7, which is greater than it, right? So if you look at it that way, you can see that 5 is a root node over here. So you can either use a DFS or a BFS, but for this example, it makes a little bit more sense, at least for me, to do a BFS. So let's do that. So what we're going to do is we're first going to set the queue. We're going to represent that by DQ. And if you're in an interview setting, then what you do is you import from collections, import deck, right? But Leetcode already has it, so not really that big of a deal. So for this one, what we have to do is we have to append the root into the queue. So while queue, so we have queue size is equal to length of the queue. So this is standard BFS stuff, right? We're appending the root here, and we're setting our queue size, and now we're just going through all the nodes. In the tree, so for blank and range, and we're gonna go queue size. Now we're gonna proceed by popping the we'll call this current node is equal to queue.pop left. So basically, if you understand how a breadth first search works here, what we're gonna do, let me bring up my notepad here. Alright, so given that we have 2, 2, 5, 2, 2, 5, 5, and 7, right? So what we do here is this is going to be our queue size, right? And then we're just adding them to the queue here. So we have 2 here. Basically what we're doing is we're going to take her out and we're going to perform some operations here, right? So we're going to represent left is equal to current node dot left, right? Right is equal to current node dot right. So if left and right exists, so given that you either have exactly 2 nodes or 0 nodes, then this property would stand. So what we do here is we want to take the max of the 2 nodes here. So we're going to take the max. I'm going to call this current max is equal to the maximum of current node dot left dot val, or actually I will call it left dot val, right dot val. So if cur max is greater than current node dot val, so basically what this is going to do is it's going to handle our edge case here. So you can see here that it's 2, 2, 2. So if this is not valid, it's obviously going to skip it, because what we need to do is we need to represent our answer, and what we're going to do is we're going to import the max size. I just want to represent it by a max integer, right? So in an interview setting, what you would do is like from sys import max size, right? So the current max is greater than current node.val. What we're going to do is we're going to represent our answer to now be the minimum of answer and current max, right? And lastly, what we need to do is we need to append our children. So if left, what we're going to do is q.append left. As you can see here, I'm just kind of lazy, so that's why I'm doing that. But you can write it out if you want. If right, q.append right. And lastly, what we're going to do is we're going to return answer if answer is not equal to sys.max size, else we return -1. And as you can see here, pass the test case, and we submit, and it's successful. So if you enjoyed the video, don't forget to hit like, comment, subscribe, and I'll see you next time.